Does human age slow down in space? How is it possible? Let's find out the truth. 1. How astronauts age slower in space than we do on Earth. Time as we know it is not constant. The concept of time dilation in space is a mind-bending reality derived from Albert Einstein's theory of relativity. According to this idea, time is not a constant, but rather a variable influenced by speed and gravity. The consequences of this theory are substantial, as demonstrated by countless tests. Astronauts orbiting the Earth perceive time differently than those on the ground, resulting in the strange occurrence of aging at a slower rate when in space. 2. Gravitational time dilation. Einstein's theory of general relativity introduces the concept of gravitational time dilation. It describes how the presence of mass bends the fabric of space-time, causing time to move at varying rates depending on the intensity of the gravitational field. The gravitational force is weaker in space, where time runs slightly faster than on Earth. This effect, however minor, means that astronauts in orbit perceive time at a slightly different rate than those on the planet's surface. 3. Relative velocity and time dilation. Einstein's theory also includes relative velocity time dilation, which is detailed in the special theory of relativity. It explains that as an object moves faster, time slows down in relation to an observer at rest. Astronauts traveling at great speeds in Earth's orbit suffer this type of temporal dilation. Their relative velocity to individuals on Earth indicates that they are aging at a slightly slower rate, as proved by precision atomic clock measurements. 4. The twin paradox. Consider this scenario. An identical twin travels through space at incredible speeds, while the other twin stays on Earth. According to Einstein's theory of relativity, time acts differently for moving things than it does for stationary objects. So, when the traveling twin returns from their space adventure, something interesting emerges. Despite having spent the same amount of time, the traveling twin will have aged less than their counterpart. This phenomena, known as the twin paradox, demonstrates the interesting consequences of time dilation, in which time appears to pass more slowly for moving objects than for stationary items. It's a fascinating science concept that calls into question our basic conception of time. 5. Practical implications for astronauts. Astronauts on the International Space Station, ISS, experience the impacts of time dilation on a regular basis, albeit on a very small scale. According to the European Space Agency, after months in orbit, individuals age 0.005 seconds slower than people on Earth. This difference is little but significant since it gives real-world proof for the relativistic effects anticipated by Einstein's equations. 6. Future exploration and time dilation. As humanity pursues greater space exploration, the implications of time dilation will become increasingly important. Missions to distant planets or even other star systems will necessitate careful consideration of relativistic effects on time and aging. The notion of astronauts returning to Earth substantially younger than their counterparts who remained behind is no longer science fiction, but rather a future possibility that must be considered when planning long-term spaceflight.